Good evening and welcome to the Oliveboard platform. My name is Marut Sharma, your logical reasoning expert, and we are here today to start and finish the new topic, single topic, which is counting of figures. Right? Now, good evening, guys. Good evening. So, this topic is also based on figures, right? On images. But unlike non-verbal, there is some sort of a calculation involved here. Okay. Now, I will give you a brief revision again, like every session, assuming that you are well aware of the in-depth concepts here, right? But of course, I'll touch base everything, but we'll not get into extreme details, right? This being the crash course. So, we'll start with counting. Now, a few things to keep in mind. Whenever I talk of counting, a lot of SSC aspirants have only one thing in their mind, that this is probably he's talking about counting of triangles, maximum, majority of the times. Sometimes you'll feel that squares and rectangles. But counting has a lot to itself apart from this. Okay, so there's a whole section of counting which you don't know about. They are simple questions though, and they have been asked in the past, but the frequency is extremely less. Even as far as triangles and squares and rectangles are concerned, up until a long time, I think up until 2 years ago, the questions were quite consistent. Every shift used to have at least one question from counting. But in the last 2 years, the story has changed a bit, and we haven't seen questions from counting except for maybe one or two shifts somewhere. And this year, again, there was no image-based questions, and a lot of people are actually pointing out the logistic reason behind it. But to be fair and square, this is still a part of your syllabus, so definitely we need to go through it and we need to master this concept overall. Now, what is the problematic point here? The problematic point here is that the options, see, ideally what you need to do is there is a figure, a central figure given to you, which is further divided into multiple smaller figures inside. Okay, and then there are some external attachments also sometimes, and you need to find the total number of smaller figures which are involved, right? Now, most of you will approach it manually, that they'll count one and one by one each figure, but that is not going to give you the accurate answer. Because the issue here is the options are very close. So supposedly you have counted, let's say 12 triangles. Your options will be 11, 12, 13, 14. So you will always be in a confusion. By chance, have I counted an extra triangle or am I counting a triangle less? And that will cause that doubt in your head, and that doubt will create, either you will end up taking a lot of time by re-evaluating, recalculating, recounting again and again and verifying, or eventually you will drop the question and move ahead. So it will prove useless to you. So to overcome this, you need to be smart about it, right? Now, whenever we talk of counting, before the actual discussion, I want to tell you how to approach this question. So of course, there are some short tricks, there are some formula, but alone with those, you will not be able to solve your question. Of course, there is manual counting, but alone with that also, you will not be able to solve the question. So each time, for each question, you have to take the combination of both these concepts. That is, if you have a single figure in front of you, you will always break it down into smaller figures where you can easily apply the short tricks and formulae. Once you apply them, you will find this total. So this will be one benchmark number, but this is not your final answer. Once you attain this number, then you will observe the whole image together as a single set, and then identify those figures which were ignored when you had broken this figure down. Count those figures manually, maybe 2 or 3, 4, 5, whatever. Add it to your benchmark number, and that will be your accurate answer. So accuracy becomes of paramount importance when you're attempting this question. Of course, the speed is important, but accuracy is more important because of the very close options. Now, when I talk of counting, there are two major types of counting, or two major types of figures which are presented before you. One is 3D figures, the other one is 2D figures. Okay. Now, in terms of 3D figures, they'll mostly ask you questions based on cubes and cuboids only. So what happens here is, the only crux point here is that you will count the hidden figures also. Hidden figures will be counted, which you don't count in the 2D section, but in 3D section you will. So I'll just give you a brief example here. Not a very neat one though, but The question is, how many cubes are there in this figure? How many cubes are there in this figure? So generally, in haste, a lot of people will say 1, 2, 3, 4, 5 because they can see 5 cubes here. But the answer will be 6. Why? Because these 2 cubes which are placed on the top are actually placed on 2 cubes which are placed at the bottom, right? So the bottom layer has actually 4 cubes, okay, and then 2 are placed on the top. So there are total 6 cubes, correct, very good. We are counting the cube which is there at the bottom leftmost corner, which we can't see here, right? But despite that, you will always count it. Why do we do this? Because this is a 3D figure and we are representing it on the 2D plane. So obviously we can't represent the whole aspect. We can't represent one dimension only. So you'll not be able to see the figure. So you will assume it exists and you will count it. But vice versa, in a 2D figure, if you see something is hidden, for example, if you see a triangle like this, if I ask you how many triangles are here, you will say there is only one triangle. Okay. Okay, no, not in this case, sorry. Yes, if the question asks you how many squares are there, so you will say only one square is there, which is this one, the main square here. Okay, you will not count these individual squares or rectangles. Why? Because they are hidden partially. So they are not your valuable counts. Or if I give you something like this. So how many triangles are there here in this figure? Only one triangle. Only one triangle, because this one is being hidden. So we will not count it as a triangle. So this is how you approach in a 2D figure. Hidden figures will not be counted there. Hidden figures are counted here. That's all you need to know about the 3D structure. Now in 2D, we have 3 major types of figure sets. First one are straight lines. Next one are polygons. And the third one are circles. And polygons are further divided into 2 types. Triangles. And I would say quadrilaterals, which will consist of rectangles and squares. Okay, so this is how your complete counting looks like. All right, now let's come to the 2D figures. How will we count straight lines? So whenever you have a complex figure, let's say something of this sort, they will give you a complex figure which will have multiple lines in various directions. Okay. And now they are asking you how many straight lines are there, how many minimum straight lines are there to form this figure. So what you'll do is you'll have to, obviously you can't draw anything because you're looking at this on the screen. So you will actually look at this, you will break it down into 3 parts, the horizontal part, the vertical part and the slant part, and you will just add them. Okay, so in this case, you will observe that, okay, if I look at the horizontal part, how many lines do I have? I have 1 line, I have 2, I have 3, 4, 5 and 6. So I have 6 horizontal lines. When I talk of the vertical line, how many vertical lines do I have? I have 1, 2, 3, 4 vertical lines. And the rest of them are slant lines. How many slant lines do I have? 1, 2, 3, 4, 5, 6, 7. 5, 6 and 7. Okay, 7 slant lines. So there are 17 straight lines in all which are formed here. Right, so this is how you will observe. You will break it down into smaller sections one by one, always horizontal, vertical and slant, and then you will count them. That's how you will progress in a straight line case. What about triangles now? How do I count triangles? So for triangles, there are some set formulae, some set short tricks which I'll tell you now. But always remember, the short tricks also will be of 2 categories. So one category is a formula based short trick. That means there is some sort of a trick involved in counting. The other one is a fixed result. Fixed result means there is a result, you have counted it once manually, you have got the answer and now you have remembered the result. You have memorized the result. So you're reusing it anytime that figure comes in front of you. You have to have a combination of both of them together for each figure so that you can solve the questions quickly. Okay, so if you look at this one now, here the triangle is vertically divided into multiple parts from the same vertex. How many parts are there? 4 parts. So what will you do? You will count the number of parts, part 1, part 2, part number 3, part number 4. You'll take a sum of all these numbers to get 10 as your answer. So there are 10 triangles here in this figure. And this 10 includes all the triangles, single triangles, double triangles, triple triangles, and the whole triangle also. On the other hand, when I am horizontally dividing it into parts, so I will just count the number of baselines or the horizontal lines. So 1, 2, 3, and also the main baseline, 4. So total, the largest baseline will give me my total answer. That is, there are 4 triangles here. Triangle number 1, then 2, then 3, then 4. Okay. But the main question is, they will never ask you a question like this. Okay. It's very rare that they ask you a question with either of these types alone. They will always combine both of them. Okay. They'll always combine both of them. So how many triangles are there in this figure? That's the question. That's how they'll ask you. So how will you approach this question? You will always find the number of vertical parts first. So for 1, 2, 3, 4, 5, 6. There are 6 vertical parts here. Total is 21. Okay. Total is 1 plus 2 plus 3 plus 4 plus 5 plus 6, 21. And then how many horizontal parts are there? So you will say 1, 2, 3, 4 and 5. And you will just multiply the two of them. So the answer is 105. There are 105 triangles here. How? So 1 to 6, 21 triangles in this section. Then 21 triangles in this section. Then 21 triangles in this section. 21 in this section. And 21 in this section. So total 105 triangles. This is also inclusive of all the main triangles, smaller triangles, all types of variations are there. Okay. Then we come on to the square. If there is a square which is divided by the diagonals into, or it is just divided into 4 equal parts, 1, 2, 3, 4. Just double it, you will get the number of triangles here. How? 1, 2, 3, 4. Then we take these 2 at a time, then these 2 at a time, then these 2 at a time, and these 2 at a time. So 4 more triangles, 2 at a time. Total 8 triangles here. How many parts are there here? 8 parts are there. 2, 3, 4, 5, 6, 7, 8. So the total is 16 triangles here. But it does not necessarily have to be a diagonal part or a part which is passing through the center like this. I can divide this also and this also. I can further divide it into 2 more parts. So now there are how many parts here? 10 parts here. So now there will be 20 triangles here. So that's how you will approach these questions. Okay. Now these are your formulae or trick based questions. Okay. Trick based formulae. So that means you have some sort of short trick or some sort of formula which will help you to find the number of triangles. Now we look at the fixed results. Fixed results for triangles will look like this. Okay. So supposedly there are 8 total triangles here. So there is 1 triangle and 2 triangles. 6 pointed star is being formed here by 2 triangles. How many triangles are there? 1, 2, 3, 4, 5, 6. The main one 7 and this one 8. So there are total 8 triangles. Manually you have counted once. Now you will always remember it. So if at all you come across a figure like this, you will have your 8 triangles with you right away without thinking twice. And sometimes what they can do is they'll complicate it like this. So they'll give you a figure here. They'll give you a distribution like this. They'll give you like this. Then they'll make it like this. Okay. Then they'll again divide it like this. And then they'll again divide it like this. Now they'll ask you how many triangles are there. So each section you'll apply the formula. You'll find the number of triangles and then the remaining triangles and add and get your answers. So that's how you will approach this question. What about this one? Total triangles is equal to 10. How 10? So this is a 5 pointed star. So we have 5 triangles here already and each line segment here, each line here has a triangle on it. So if this is the line, I have a triangle on it here. Then if I take this whole line, complete line, okay, then I have a triangle here. Then if I take this whole complete line, I have a triangle here. So I have total 5 lines. 1, 2, 3, 4, 5. And each line has a single triangle. So 5 more triangles, 5 plus 5, 10 triangles in all. Okay. So it's not like number of lines multiplied by 2. That's not what is happening. There is no trick or formula. We have manually counted the triangles and it may change. Okay. So you have to remember this. Not in your SSC exams, but in some of the competitive exams, this question has been directly asked. So they've given you a 5 pointed star and they've asked you how many triangles are there. Observing it manually at that moment becomes difficult. So if you remember the logic, it will be much easier for you. I'll give you another logic here. See, so far I've told you that if you have a square, okay, which is divided, let's say, into parts like this, right? If I have a square which is divided into parts like this, so what did I say? You will just count the number of parts and double it, right? So I had 8 triangles here. But if I remove this one line, okay, so this figure will always have 5 triangles. It's a very common figure. How 5 triangles? 1, 2, 3, then these two 4 and these two 5. Now it can be in any order. It can be like this. It can be like this. In any way it can be, but this will always be equal to 5 figures. So remember this also as a fixed result. Now, it's not necessary that only these many are fixed results. If you come across multiple figures which are always repeated, you can remember them as your fixed result yourself, so that you can reuse them in your examinations whenever necessary. Okay, now let's talk about squares. Okay, about squares. So about squares, you have these grids in front of you. How will I count this? So we have a habit. Since childhood, what we do is 1, 2, 3, 4, 1, 2, 3, 4, sir, 4 into 4, 16 squares are there. And then I'm telling you, no, that's not the right answer. So you think a little bit and you say, oh wait, I forgot the main square. Sir, 17 squares are there. No, both of the answers are incorrect. Because when we are counting like this, we are only counting the number of smaller squares, individual squares. We are not counting the squares which are formed as a combination. We are not counting this. We are not counting this. Do you understand? We are not counting this 3 into 3 square. So that will change the count totally. So how do we do that? So you'll always count the number of rows. How many rows are there? There are 4 rows. How many columns? 4 columns. And now you will multiply the number of rows into number of columns. Okay. And then you will keep reducing it by 1. So the next one will be row minus 1 into column minus 1. Next will be row minus 2 into column minus 2. We'll keep multiplying this till the time we reach 1 at any one place. Even at any one place, if we get 1, we'll stop. Why? Because the next one will be 0. So that's useless. So we'll stop till here. We'll find their products. We'll add them and that will be our answer. So in this case, if I go around, what will be my answer? So it will be 4 into 4 first, followed by 3 into 3, followed by 2 into 2, followed by 1 into 1. So what do I get? I get 16 here, I get 9 here, I get 4 here, I get 1 here. So this is 25 plus 5, 30. So there are total 30 squares in this figure, in this matrix. And these 30 squares include your primary, outer square, etc. everything. What about this one, an unequal matrix? How do I approach this? So there are 3 rows and 4 columns here. Same process you will repeat, 3 into 4, 2 into 3, 1 into 2. And you will stop here because next one will be 0 into 1. So that's useless. So what is the answer here? This is 12, this is 6, 2. So this is 20 squares here. But this time, see here automatically counted the outer square because of the equal rows and columns. Here it is not going to count the outer square at all. Why? Because the outer square can never be a square. And why is that? Because the length is different than the breadth. 4 squares here and 3 here. So it is not going to count. The formula is set in a way that this is counting the other squares now. Okay. So this is how you approach it. If a square is in a matrix. Okay. Now these are the formulae based. What about fixed results? These are the fixed results for squares. Right? For fixed results of squares, these are the cases. So if a square is divided into 4 parts by a plus sign between it, you will straight away count 5. Why? 1, 2, 3, 4 and the main one 5. So no thinking twice. You will straight away count 5 squares here. You look at this figure, straight away count 5. Okay. If a square, if in this case I join the midpoints like this, these midpoints, if I join them, what do I get? I get another square. Right? That's precisely what I'm doing. So I already had 5 squares. I'll join this one more and I'll have 6 squares now. Okay. In this case, I have this figure 5 for this and 5 for this, total 10 squares. But this one is repeated twice. So I'll cancel this out one time. So 10 minus 1 is 9. So I'll have 9 squares in this case. Okay. And what about this figure? This figure is exactly the same figure on the top, just that we have added these cross lines here. This one line and this other line. These are the 2 cross lines I have added. What does that do is that makes a plus sign in between here, which adds 4 more squares to it. Square number 1, square number 2, square number 3 and square number 4. So I already had 6, I'll add 4 more, so I'll get a total of 10 squares in this case. Okay, how did I obtain this figure? So this was precisely a single square, okay, which was first probably divided into these squares like this. Then it was divided like this. And then I added this from end to end on the diagonals. So this is what it looks like, and this is always 10 squares. Okay, cool. So if you have a complex, let's say, figure and you have these individual figures inside, you will straight away count them as 5 or 9 or whatever to make it quicker and easy. Now, if I talk of rectangles, so this need not be a rectangular matrix. This can be a square matrix also. It's just elongated here. Now my count will slightly change. Supposedly, if I had a single rectangle here, let's say, which was divided into 4 parts. The question is how many rectangles are here? So I will just count the number of parts like in triangles. 1, 2, 3, 4, and I'll add all of them to get 10. That's it. So there are 10 rectangles here. 1, 2, 3, 4 individually, then 1, 2, 2, 3, 3, 4, then 1, 2, 3, 2, 3, 4, and then 1, 2, 3, 4, the whole rectangle. Everything when I count together, I'll get 10 here. But when it is in a 2D matrix form, then what will I do? I will say 1 plus 2 plus 3 plus 4. I'll have 10 rectangles here. And 1 plus 2 plus 3 along the column, I'll have 6 rectangles here. I'll multiply both these numbers to get 60 rectangles in all. I can call them 60 rectangles or I can call them 60 quadrilaterals also. If my question gives me a matrix like this and asks me how many quadrilaterals are there, then also I will say 60 only is my answer. Okay, signal lost? No, I believe it should not be the case. Everything is perfectly fine here. Refresh at your end and see. Hello? Yeah. Okay, working. Perfect. Right? So this is how it is. 60 rectangles. But now my question asks me how many only rectangles or pure rectangles are there in the figure. Now this changes the game. Pure rectangles means when I'm counting it this way, I'm actually counting the squares also, because squares are also quadrilaterals and squares are also rectangles. So if I'm saying rectangles, that means I'm counting both rectangles and squares. But when the question is asking me only rectangles or pure rectangles, I need to eliminate the squares. So there is no direct method here. I will count the total number of quadrilaterals and I'll subtract the number of squares from it to get my answer. How do I do it? How do I count the number of squares? So this is a 4 into 3 matrix. 4 into 3, 3 into 2, 2 into 1. So this is 12, 6, 2. So these are 20 squares. Subtract 20 and 60 to get 40 only rectangles. 40 pure rectangles. Okay. So if the question asks you how many pure rectangles or how many only rectangles are there, this is how you will approach it. You will find the number of quadrilaterals or normal rectangles, find the number of squares, subtract them and you will get your answers. Okay. There are no direct or fixed results for rectangles. All right. Now coming back to the initial section here. So we have covered triangles, we have covered quadrilaterals, rectangles and squares also. Now what about circles? So in case of circles, there will be a complex figure to you. There are two approaches given here. Either I have a circle, okay, I'll have one origin point and I can see multiple circles emerging out of it, something like this. Okay, I've not drawn it correctly, but just assume. So now they're asking me how many circles are there in this figure. So I will pick up this origin point and I will see how many lines are going out of it or in the next direction, like coming out of it. 1, 2, 3, 4, 5, 6. 6 these circles and 7th one is the one here. So there are 7 circles here. Okay, so this is one way of counting. You will just look at the origin figure. And the other one is there can be complex circles like this. Now they'll ask me how many circles are there in this figure. So it will become quite difficult for us to visualize one by one. Okay. Yeah, I'll do that. Let me complete circles first, then I'll go back to it. So in this case, you have to have a visual line. you have to have a visual line. In this case, actually going horizontally will help you out along the row. So you see there's a visual line here. So you will see there are 1, 2, 3, 4, 5 circles here in this visual line. Next visual line I have 4 circles. Next visual line I have 4 circles again. Next visual line I have 5 circles. Then I have 3, then I have 2, then I have 1. So this is 5, this is 4, this is 4, this is 5, this is 3, this is 2, this is 1. Now I can easily count the total and get my answer. Okay. So this is how you count circles. So this is precisely how you handle any topic of counting. Let me quickly revise the rectangle part with you. So formula for rectangles actually. Okay, see, quadrilaterals or rectangles. If the question is asking me how many quadrilaterals are there in this matrix or how many rectangles are there in this matrix, the approach is I will count the number of parts along the row. So 1 plus 2 plus 3 plus 4, 10. And I'll count the number of parts along the column. 1 plus 2 plus 3, 6. I'll multiply both these numbers to get the number of quadrilaterals or rectangles. But if the question asks me how many only rectangles or how many pure rectangles are there in this figure, so this is not pure rectangles or only rectangles. This is also counting the squares. So now when I ask you pure rectangles, that means you have to eliminate the squares. How do you do that? So you already know how to count the squares, right? The matrix is 3 rows and 4 columns. So 3 into 4, 2 into 3, 1 into 2. You multiply this, you get 20. 20 you will subtract from 60, you will get 40. So there are 40 pure rectangles in this matrix. Okay. Because all squares are rectangles, but all rectangles are not squares. Got it? So that's about it as far as the concept is concerned. We'll quickly start with the questions, but I want to discuss the previous year questions with you first. Right? So just give me a moment while I set it up. So they are not labeled though, but they are all previous year SSC questions. Okay. Majorly from CGL exams only. Some of them are actually very interesting questions. They will eat up on your time. They are not very difficult though. None of them is very difficult, but they are just very observational. Let's quickly start solving them. This is the first question. Answers in the chat box, everybody. So how do we approach this question? As I told you, you will approach it never together. You'll approach it in parts, right? So I will check the main figure first. Main figure is divided into how many parts? 1, 2, 3, 4, 5, 6, 7, 8. So there are 16 triangles. And then I look at this one part also. This one part is divided into 2 parts. So 1 plus 2, 3 more triangles here. Total of 19 triangles, which is option B. Correct. Very good. Right? Next. Okay, look at this now. How many triangles are there in the given diagram? So we can divide this into multiple parts. So you'll see this part is a quadrilateral which is divided into 4 equal parts. So we'll have 8 triangles here. Then we'll take up this triangle which is divided into 2 parts. 1 plus 2, so 3 triangles here. 1 single triangle here. And then a lot of people see the whole triangle. See, I told you, divide it into parts. Write this. Then look at the whole figure as a whole and then see what are you missing. So you're missing this whole triangle. Nobody has counted this one. 1, this 2, and then this complete triangle 3. So there are 3 more triangles here. So this is total is 15 triangles. Option A. So that's precisely how we are going to make errors. Okay. You're going to miss out on a few triangles and then eventually you will wind up getting the incorrect answers. Yes, next. Yes, look at this. How many triangles are there in this figure? So now here, as I showed you, this part will show me 5 triangles here and this one will show me 5 more triangles. So total 10 triangles I already have with me. Then this part on the top, 3 and 3. I have 6 more triangles here. Then this single triangle I will see and this triangle I will see. So I will add 2 more. A lot of people end up doing this and they get 18 triangles as the answer. But obviously that's not there. So what else? Now, if I look at the whole figure, what can I see? I can see this triangle here, 1, this one here, 2, and the whole triangle, 3. Similarly, this triangle here, 1, this triangle here, 2, and the whole triangle again, 3. So what is the answer now? 6, 6, 12, 14, and 10, 24. Option C is the correct answer. Now, after getting 24 triangles also, some of you will feel that, okay, wait, am I counting a triangle less? Maybe it's 25. Then again, you will spend some time here. So you have to master this concept where you have that confidence in you that you have counted it correctly. This one is pretty easy. You will be able to figure it out very quickly. Okay. So in this case, we have a triangle which is divided into 1, 2. So three total, and 1, 2, 3, 4. So 3 fours are 12. Then we have this triangle here, 3, 3 into 3, 9. This triangle 3 and 2, 6. Add all three of them because there is no other common triangle among them which you are missing out. So this is 15 and 12, 27. Option D. Next. What about this one now? In here, if you see this part, this square is divided into 4 parts. So we have 8 triangles here, 8 triangles here, and 3 here. This much everybody can see. So 19 everybody will figure out and will mark it here very quickly. But you will fail to see this. When you see the whole figure together, you see there is one single triangle which is formed like this and one single triangle which is formed like this. The answer is 19 plus 2, 21. Okay. If you're counting any extra triangles, they are all repeats which you're doing. How many triangles are there in this figure? It's actually very easy. The inner square is divided into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. So 16 triangles there. And the outer square is also divided into 8 parts. So 16 squares are there. 16 triangles are there. So 32 is the answer. That's it. There is no other common triangle whatsoever. Okay. Next. This is very easy. How many parts? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts, 16 triangles. That's it. Nothing else. No rocket science here. Next. This is a good one actually. Now in this case, if you see, a lot of people will consider this as a quadrilateral again, but you can't do that because this is not a straight. So it's not a quadrilateral here. This is not a straight line. This is a curve here. That means this is a different line and this is a different line. So you'll have to break it down into different parts. Okay. So we'll pick up this triangle first. Broken into two parts, so three triangles. Then this triangle next. Broken into three parts again. I mean two parts, three triangles. Then this triangle here. Three again. And this triangle is single actually, this one. Here. Why? Because this is not a triangle, it's a quadrilateral if you see clearly. Four sides it has. Because this line is not precisely starting from here. Okay. So one more for this one. That's it. Now you will look at combo triangles wherever we are missing out. So when I try to look at that, I can see this vertical whole one as a single triangle. This vertical whole one as a single triangle. Two more. Then this whole triangle we did not count. And this whole triangle also we did not count. So two more. How many do we have? 14. And that's precisely our answer. Option B. Okay. Next. This is again very easy. How many triangles are present in the given figure? So 8 parts here. So 16 triangles in this part. Then I can see this part divided into 3 parts and 2 lines. So 6 here and 3 here. So 9 and 16, 25. That's it. There is no other triangle which is there. So option D is the correct answer. Next. In this, if you see, there are 3 different types of figures again. So this is figure 1. This is 3 into 3. So 9 triangles here. Again, the same figure set here. 3 into 3, 9 triangles here. And same figure set here. 3 into 3, 9 triangles here. If you look at them together, there are no other extra triangles which you are missing out on. So 27 is the accurate answer. Alright, now let's switch to squares. Squares and rectangles. How many squares are there in this figure? Right. So you will have to divide this into 2 parts. So what are the 2 parts? Part number 1 is this matrix. Now we already remember that if a 3 into 3 matrix is there, how many squares were there? 14, right? 3 into 3, 2 into 2, 1 into 1. So you'll remember the results actually. 1, 2, 3, 4. 14 plus 4, 18. That's it. Okay. Next, how many rectangles are there? Also, what you do is, apart from finding rectangles, also find only rectangles. So find normal rectangles also and only rectangles also. So normal rectangles are quite easy, I think. If I add the parts here, part 1, 2, 3, 4, 5. So there are 15 rectangles here. 1, 2, 3, 4, 5. 15 here. 15 into 15 is 225. That's my answer. Total 225 rectangles or 225 quadrilaterals. But how about only rectangles? So for that, I'll have to subtract the squares. How many squares will I have? 5 into 5, 4 into 4, 3 into 3, 2 into 2, 1 into 1. Correct? So how many squares are there? 25, 16, 9, 4, 1. So this is 25, 25, 50 and 5. 55 squares. Just subtract 225 and 55, you get 170. Okay. This was not asked in the question. This is an additional thing which we are doing. If at all a question can be asked like this, then this is what you'll answer. Next. How many squares? Okay, this one is actually pretty easy. Just visualize. Not everything is formula based. 1, 2, 3, 4, 5. That's it. Okay. Next. How many squares again? Now divide this outer matrix. So look at this outer matrix first. Ignore the inner figures. So we have 1 row, 2 row, 3 rows and 2 columns. So we'll have 3 into 2, 2 into 1. That's it. So how many squares? 6 and 2. So 8 squares we have here. Now this whole figure I've told you, we will add 5 right away. So we'll have 5 here. Then 1 and 2 here we'll add 2 more squares, and this one little square we'll add more. So manually we'll add 8 more squares. So 16 is our answer. Okay. Next. This is actually a good one. A lot of people make errors in this question. Slow down and observe. How many rectangles are there in the following figures? 1, 2, 3. So 6 in all here. Then 1, 2, 3. 3 more. So we have 9 rectangles already. Now we'll have to look at combo, that is with manually. So this one we did not count. 1. Then this one 2. The whole. And then this one 3. That's it. 3 more rectangles we'll have. So total 12 is the answer. Okay. Next. This is pretty easy. Right away you can get the answers here. Okay. See, 1 plus 2 plus 3, 6 rectangles here. Okay. Then 1, 2, 3, 3 more rectangles here. Now every smaller part is accounted for. Now the large part. So this one part, these two rectangles will form one part. One single rectangle. Then starting from here, this whole thing will also be a rectangle. 2. And then starting from here, this whole thing will also be a rectangle, no? Won't it be? So 3 more. 12. Okay. Cool. Now here this is 34 we know because the middle grid, the grid is a 4 into 4 matrix. You already know 4 into 4 has 30 squares. By now you have remembered it already automatically, and we'll add 4 more, so we'll get 34 here. Option B. Okay. So when you repeatedly practice a lot of questions, you will start remembering some results automatically, and then you can use them for your benefit. So 3 into 3 matrix again. So we have 14 squares plus 5 plus 5. That's simple. Okay. 24. Next. This is actually a good question. Very nice one. We often miss some particular squares here getting the incorrect answer. If you see, the answers are also very close. They're not very far off. 57, 66, 71, 76. But the options will actually come to your rescue here. See, again, we'll divide it into parts, right? So I'll take this grid individually. And what will I have here? 1, 2, 3, 4, 5 rows, 3 columns. 5 into 3, 4 into 2, 3 into 1. How much do I have? 15, 8, 3. So 26 squares I have in this figure. Then I'll pick up the grid here, but I'll pick up obviously a continuous grid only, no? So this is a better option for me. So I have 3 rows here and 6 columns here. So 3 into 6, 2 into 5 and 1 into 4. So this is 18, 10, 4. So 32 squares I have in this grid. Then quickly what I'll do is I'll count these 5 squares here. 5, 6 and 7. Now if I take the total, I'm getting 65 squares right now. The only luck which is in my favor is that 65 is not there in the options. Otherwise, a lot of you by now would have marked 65 and moved ahead without thinking twice. Correct. Only because of the options you are saved here. So now when you visualize, you will see that after drawing this square with this grid, you see that this square nobody counted. We missed this out. Okay. So this is that one extra square which you need, and that will make the total as 66. Okay. Next, how many squares are there in the following figures? Make sure the question is asking you squares, not triangles. Just a few more questions. One more square based question after this, and then one straight line based question, one circle based question, then we'll be done for the day. Right, now what are we looking at here? So we will look at this central grid separately. Okay, this grid has 1, 2, 3, 4 rows and 2 columns. So we have 8 and 3, 11 squares here. Okay, then after 11, we'll pick up these 1, 2, 3, 4 and the whole square 5. So technically this should have come directly from you, but any which ways, 16 squares like this. You can go like this also, or the other method is that you consider this middle square separately as a plus with a plus sign here. So there are 5 squares here. Then you consider the external square with a plus sign. So you have 10 squares there. Total 5 plus 5. Then 1, 2, 3, 4. 4 more, and then 1 and 2. 2 more. So either which ways you will have 16 squares only, but this one is a faster method. Okay. See, can you see how the close options are actually ditching you? Because the moment you get your answer here, there's a very high tendency you will mark it and not recheck it at all because of the exam haste. So if at all you come across a counting based question in your exam, no matter how much in a hurry you are, there should be a speed which should be maintained, a momentum which should be maintained. But make sure you just go through the manual figures with slightly slowly. I'm not saying consume a lot of time, but slow down a bit. Just observe and then move ahead. Be cautious. Okay. Very good. Excellent. So in this figure, if you observe this complete grid, 1, 2, 3, 4, 4 into 3 matrix. I have 12, I have 6, I have 2. So I have 20 squares already. But don't count these as 5 squares each now, because that is a plus sign, not a cross sign. This is a single square only. So technically 20 is there. But if you look at the whole figure, this single square is also there, which a lot of you miss out. So 1, this smaller square 2, and this smaller square 3. So there are 3 additional squares which will make the total as 23. Okay. Now, one straight line based question I want to give to you. 2 more questions, that's it. One straight line, one circle. So that every topic is touch based. That's it. This is a straight line based question. Count how many minimum straight lines are there to make this figure. So we will try not to draw or highlight it, okay? Because that's how this will be asked in your exam also. So you'll have to just look at the screen and count. You cannot actually go ahead by marking anything. So we'll have horizontal, vertical and slant. Just now isolate the horizontal lines in your head. When you're looking at the figure, just look at the horizontal line. So 1, this whole line is 2, 3 and 4. So there are 4 horizontal lines for me. Count the vertical lines. 1, 2, 3, 4, 5 vertical lines. And how many slant lines? So 1, 2, 3, 4, 5, 6, 7, 8. 8 slant lines. And 9 plus 8 is 17. Option A is the correct answer. So without actually highlighting anything, I highlight it just so that you can visualize easily. Okay, but you actually don't have to highlight anything in the figures. Why? Because this, you will not be able to see this in the exam also. I mean, you will not be able to write on it in the exam. Got it? And the last circle based question, and then you can go. This is the circle based question. How many circles are there in the given figure? So in the example I gave you, we counted row wise. Here I think going column wise will help you out much better. Right. So if you look at it column wise, I have 1 column, 2, 3, 4, 5. And again, don't draw this. This is how you need to see. So I have 1 circle here, 4 here, 3 here, 4 here, 1 here. So that's 8 and 12 and 113. Option D. Right? So that's all about counting of figures. Again, the frequency has reduced for the last 2 years, but still you need to be thorough in this topic because of the options, right? And if you are well versed, then you can actually score good in this topic, because a lot of students by default, they drop it. If they come across a counting based question which is slightly complicated, they'll drop it and move ahead. So your good practice can actually push you above a lot of others. But again, don't take it on your heart. Don't take it on your ego. If at all you find, if it's a sectional timer and if you find that it can get complicated, drop it, complete the section and then come back if time permits, right? Okay, thank you so much for watching live till here, guys. I'll see you around in the next session with a new topic. Till then, you guys take care. Bye-bye. Namaskar. Jai Hind.